Well, hey, what do you know? It's that time again. It's time for the Bellringer. Today is Wednesday, so we have Bellringer, we have a little Ed puzzle lesson, and of course, we've got our book talk, chapter 4 of Stiff, which is all about crash test dummies. So let's do today's Bellringer and use this time to get some work done, and yeah, that's what we'll do.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Let me show you some of my favorite chromosomes. Yeah, here they are. I mean, chromosomes are awesome, right? You get one from each parent, right? One in the egg from mom, one in the sperm from dad. So they come in pairs. Then on the chromosomes are genes, right? So that way your genes actually come in pairs. That was Gregor Mendel's, one of his rules is spread the news, they come in twos, right? And then of course, super creative names for chromosomes. The biggest one is called chromosome number 1. Second biggest one is called chromosome number 2. Third biggest one is called chromosome number 3. Fourth is number 4. Fifth. See? Oh, wow. Pretty good. Okay, but yesterday I concentrated on this weird chromosome at the end here, which we call chromosome X. It's the only one that doesn't get a number. All of these other chromosomes are called autosomal chromosome. This is the only one that's not. So there's like 22 pairs of autosomal chromosomes, and then the 23rd pair is this X chromosome. Let's take a look at it. Chromosome X. It's a big chromosome. Don't get me wrong, it's big. It's almost as big as chromosome number 1. So it's got thousands of genes on it, thousands of them. Lots of important genes on chromosome X. We're just gonna focus on a few of them, but probably the one that gives X the greatest fame is the fact that it's got the genes to make egg cells, right? If you make gametes, one large gamete, the egg, that gene to do that is on the X chromosome. So we sometimes call it a sex chromosome because it has to do with whether or not you make egg or sperm cells. X's make eggs, right? But X's do a lot of other things too, as I mentioned yesterday, right? X's also make the proteins allow you to see the difference between red and green colors. They make the proteins that help you clot your blood. They make proteins that help you build muscle tissues. Right? So X is an essential chromosome. You need all of those things. Well, maybe not. Maybe you don't need to make eggs, but you need all these other things in order to function normally in society and as a person. Luckily, some of you get 2 copies of the X chromosome. There you go, right? One from mom, one from dad. But what's weird is some of us, me included, we only got 1 copy of the X chromosome. From dad, we got a different chromosome. We got what's called the Y. Y chromosome is a runt. It's a rinky-dink, little, teeny tiny, nothing of a chromosome. Doesn't have much going for it, really. There's almost nothing on the Y chromosome except for one gene switch. The switch that stops you from making eggs and making sperm cells. Okay? Basically, the switch has to do with meiosis, right? And that's it. That's all that's going on here. So, like, luckily for me, I have 1 copy of an X I inherited from my mom. I got the Y from my dad, and luckily my mom inherited the one I inherited from my mom. She had all the genes, like to see colors. I can tell the difference between red and green. I can clot my blood, and I've grown to be 50 some odd years old, so I obviously don't have problems growing muscle tissue. I mean, I was able to grow up, but all of those things, right? If any one of those are broken, it's going to show up if you don't have 2 X's. So we usually call them X-linked conditions. So color blindness, hemophilia, and muscular dystrophy are all X-linked conditions. That is, they're associated with the X chromosome. Because they're X-linked, they are way more common in sperm-making males than they are in egg-making females. Way more common. fact, some of them would be almost impossible. Like Duchenne muscular dystrophy would almost be impossible to be female and inherit, because you'd have to inherit a copy from mom and from dad, and dad usually doesn't live past 9, 10 years old. So the chances of inheriting a copy from him are like zero. Hasn't even reached puberty yet. All right, hopefully that makes sense. So in class today, we're gonna do our book talk, of course, and then in lab, yesterday, if you had lab, you started this genetics conditions project. If you lab today, you're gonna hear about this genetics conditions project that will start in lab today. All right, let's have a great one. Or not an average one. Or just an okay one. I mean, let's just get through it today.